Assalamualaikum everyone. We are from NBCS 1435A. We'll be present our queuing theory project. Before start, let me introduce our team members. First is me, myself. My name is Nurul Harunisa binti Anwar. The other members is Belinda Debi Majakil, Nurul Shazlina binti Muhammad Al-Hadi, and the last one is Muhammad Nurhilmi Zawawi bin Mustafa. For this group project, we have decided to choose Giant Supermarket at Putra Heights as our observation location to study the queuing system. This supermarket Giant Putra Heights is located at 3 Persiaran Putra Perdana, Putra Heights, Subang Jaya, Selangor. Its operation time start from 9 AM until 10 PM every day. We make observation at 6 PM to 7 PM. The number of server is 12 counter, but only 3 counter is available during our observation. Characteristic of queuing system. There are 4 characteristics of the queuing system that we observe. There are first arrival characteristic, waiting line characteristic, service facility characteristic, basic queuing system configurations. For the arrival characteristic, the size of the calling population at Giant Putra Heights is unlimited, means that the customer come to the Giant supermarket is at any time. Based on our observation, the pattern of arrival at the system is random, which is the customer arrive at the supermarket at any time and not scheduled because their occurrence cannot be predicted exactly and they are independent of one another. We make assumption for arrival at Giant Putra Heights follow the Poisson distribution lambda equal to 15 customer per hour, while the behavior of the arrival are patient. The customer patiently wait their turn to be served. They did not switch their position in the queue even though they have to wait more than 3 minutes because only 3 servers are available at that time and all servers have more than 2 customers.
Next is the waiting line characteristic. Based on our observation, the length of a line is unlimited, whereas Giant Putra Heights do not limit the number of customers for each counter. Well, for the queue discipline, it is first in, first out because we can see that the first customer who arrived at the counter will obtain the service first, while the last arrival receive the last service. Next is service facility characteristics. The configuration of the service system is classified by 2, which is the number of channels, and the number of phase. The number of channels, or also known as the number of servers, is a multi-channel system because there is more than one server, while the number of phase is a single phase system because the customer receives service from only one station and then exits the system. For the pattern of the service system, exponential distribution MU is equal to 20 customer per hour at Giant Putra Heights. The basic queuing system configuration in Giant Putra Heights is single channel, single phase. When the customer is done taking their needs, they will choose one server and make a queue line patiently waiting their turn to be served at the chosen server. Then after making a payment, they leave the system with their needs.
Assalamualaikum. Let's proceed to the calculation of queuing model. Let the number of arrival lambda is equal to 50 customer per hour. Number of serve mu is 20 customer per hour and the number of serve S is 1. First, we calculate the probability that the cashier is busy by using formula RO is equal to lambda over mu. Then we got 0.75. Next, we calculate the probability that there are 0 customer at the cashier, which is 1 minus 0.075 equal to 0.25. To find the average number of customers in the queue, by using formula LQ equal to lambda to the power of 2 over mu times which mu minus lambda, and the answer is 2.25 equivalent to 3 customers are in the queue. While for the average number of customers in the system, we use formula lambda over mu minus lambda, then we got the value of 3 customers. The average time in the queue, we got 0.15 hour, which is equal to 9 minute average waiting time per customer. And the average time in the system, we got 0.2 hour, equivalent to 12 minutes the average customer spent in the system. Here is the video of using QM for Windows to find the value of RHO, P0L, LQ, W, WQ.
So we have learned that the queuing model can be used to simulate a service-oriented issue where customers showed up at random to obtain services, and the service time is also a random variable. In order to decrease customer wait times and improve the number of customers that can be serviced, a firm can employ queuing theory to create more effective system, processes, and arrival management methods. The best queue discipline is first in, first out, because customers are served in the exact order in which they arrive, and it is generally believed to be the fairest way to manage queues. We also learned that for a single server queue to be stable, the arrival rate lambda must be less than the service rate mu.